Okay, so let me run through some of the properties that we will use in this chapter. So the first few property that you have learned in Sec 1, the first one, sum of angle on a straight line add up to 180. So you need to write down your reason whenever you find an angle. So you need to write down your reason and your annotation. Okay, next. I guess you will know angle at the point also add up to 360 degree. Next, the sum of angle in a triangle will add up to 180. And lastly, the sum of angle in a quadrilateral will add up to 360. Okay? Okay, some more to note, we still have our vertically opposite angle. Okay, the next three, properties 6 to 8 require you to have parallel lines. So, you can only apply these three properties when you have parallel lines. So they are alternate angle, interior angle, and corresponding angle. So in properties of circles, you will realize that these parallel lines actually do not exist anymore. Okay, so when we apply properties of circles, you can see that the properties does not actually require you to have parallel lines. So when you see parallel lines, you will think of these three property, but if don't have parallel lines, then please do not use any of the three properties. Okay, so parallel lines is a important guide to tell you which property to use. So that means that if parallel lines appear in your circle, then you have to think of using these three properties. Okay, so let's start with properties of circle. So basically what I do is a commonly used property. Uh, there's a property called the tangent chord theorem. That means not tangent chord theorem, sorry. There's this property that the angle bisector of any the perpendicular bisector of any chord will pass through the center of the circle. Okay, at the start, I do not require you to know this first because it is not common for exam to ask this question using this property. Okay, so unless you are taking A math, then A math require you to use the property quite frequently. But if you are just doing E math, typically they will not do that. Okay, so let's start with the first one. First property is called tangent perpendicular to radius. So two things to identify. You must have the tangent, you must have the radius. So the intersection of the tangent and radius will always be 90 degree. If you don't believe, I can anyhow draw. Okay, and this line, this is the radius. So the radius always come from the center. It will always be 90 degree. So you must read the question and make sure that you see the word radius and tangent. Radius you don't need to see the word, but tangent you have to see. So you can see the tangent is always perpendicular to the radius, no matter how the tangent is being drawn. Okay, and this is the reason you have to indicate after each step if you are using this property. Okay, so this first property is about 90 degree. Second property is also about 90 degree. Okay, what is the keyword for you to take note in this question? So you have to read the question and you will realize that there's something called the diameter. If you see the question and you found that, oh, my picture has diameter, then straight away you must think of this property, right angle in a semicircle. So what do you need? You need a point to be at the circle. Then when you form the triangle, it will be 90 degree. Any point will do. So I can also choose this point. You can see that it really form 90 degree as well. Don't believe, you can even choose a smaller one. I can choose a even smaller one. You can see this part is also 90 degree. Okay, other than this part of the circle, I can also put here. Okay, I just randomly choose any point as long as it is at the circle. It will always form a 90 degree. Okay, and this property is called what? Right angle in a semicircle. Why semicircle? Because the diameter cuts the circle into two parts already. Okay, and one part is just called a semicircle. So this property, these two property talks about 90 degree. Okay. Okay, next property, angle at center equal twice angle at circumference. So there's three shapes that I need you to know. This is like an arrowhead. Correct? You can see that it looks like that. Oh, okay. Next, this is what I call a diamond. Okay, it looks like a diamond. Next, the last one, I will call this a ribbon. Okay, you can see it looks like a ribbon, or you want to call butterfly also can. Okay, so when can we use this property? The condition for you to use this property is very simple. This point must be at the center. This point must be at the circumference. This point must be at the center, and this point must be at the circumference. So if it's not at the center or not at the circumference, you cannot use this property. So this is center, this is circumference. How can you see it? Okay, just imagine if I have a person standing here. He shine the torchlight. He shine his torchlight. Shine. Okay, you can see that this is the arc that the torchlight is shining. Correct? This is the arc. Okay, let's say another person stands here and he also take a torchlight. You can see that the green and the pink color will trace at the same arc. Okay, and when this happen and one is at the center, one is at the circumference, the center angle will be double the one at the circumference. This one changed to 164 lah, to be more precise. Okay, so why is it bigger? Because it's nearer. When it's nearer, you need to, your angle will be bigger. Okay, so you can see you just trace the line and they must use the same arc. As long as they use the same arc, the one at the center will be double the one at the circumference. We can take a look at the next example also. So you can see when I trace from 18108, this is the arc, correct? Then when I trace from these two lines, do I take the reflex angle or the obtuse angle? If I take this angle, right, then it will be this. Will the green and the pink color be the same arc? No, right? So what do I need to do? I should take the reflex angle. I should be taking the 216 instead of the obtuse one. Okay, because the 216 and the 10 is the one facing the bottom arc. Okay, last but not least, let's take a look at the ribbon. So let's take a look at the 38. When we trace the 38, it will go like that, correct? Can you see it shade? Then you trace the 18, you can see that, wow, they actually share the same arc. Then one of them is at the center, one of them is at the circumference. The one at the center will be double the one at the circumference. Okay, let's take a look at the fourth property. Anyway, the property name is this. You need to write it out. Okay, the fourth property is angle in same segment. Again, what shape do you see? To me, I see the ribbon. It is very similar to the one on top. Similar, right? But what is the main difference between these two ribbons? Okay, so I need you to see. You can see that this ribbon, this is at the circumference. This point is also at the circumference. This point is also at the circumference. This point is also at the circumference. So the difference is none of them is at the center. The corner of the ribbon is all at the circumference. So if this happens, correct, then when you trace this trace to this is the arc. If you use this, you trace. They also at this arc. What happens is if they trace the same arc and both is at the circumference, these two angle will be the same. Okay, let's take a look at the other side. Okay, let's say this angle, you see I trace this angle, it will point to this arc. And when I trace this angle, it will also point to this arc. So if now they share the same arc again, but both of them are at the circumference. So the angle is the same. Okay, for this ribbon, the one at the center is double the one at the circumference. For this property, the angles are the same. Okay, so this angle is 66, this is also 66. This is 21, this is also 21. So this property name is actually called angle in the same segment. Okay, next one, what should you look out for? You should look out for a four-sided figure that touches all the corners, that touches the circumference. So you can see it touches the circumference, it touches the circumference, it touches the circumference, it touches the circumference. You have a four-sided figure that touches the circumference. And what will happen? These two will add up to 180. The opposite angle will add up to 180 degree. So whenever you see a four-sided figure that touches all corner, think of this property. And this property, short form of reasoning, is called angle in opposite segment. Okay, last but not least, this is the only property that is out of the circle. So basically what you need two tangent. If you have any two tangent and they intersect at an external point, then we can say that this triangle is congruent to this triangle. That means the angle is the same, the length is the same. They are exactly two triangles, but they are being flipped over. Okay, one last unknown property, like not very official property, but it's actually quite logical, is actually the radius of circle. If you have a triangle that looks like that, okay, because this is the radius of the circle, this is also the radius of the circle. We need to know that because of this forms an isosceles triangle because the radius of the circle has the same length. Okay. This is just a very quick recap and of your 6 important properties.